Hello everyone. In this video session, I'm going to discuss about Coriolis effect. See, Coriolis effect is a favorite area of UPSC. If you see the previous year questions, you will understand that they have already asked questions from this particular topic twice. Okay, and see, we will be solving this question at the end of our session. So, now we will start our discussion. Speaking about the Coriolis effect, the first thing that should come to your mind when you hear the term Coriolis effect means the deflection. Okay, see, the effect of Coriolis force or Coriolis effect means, say, if a particular fluid or a moving object, it is moving from, say, equator to poleward region, this will undergo a deflection. It will not reach its destination place as such. There will be a deflection. And this deflection will be different in both hemispheres. In northern hemisphere, the deflection will be towards right of its path, and in the southern hemisphere, the deflection will be towards left of its path. Okay, we'll see that. Another thing, so what do you mean by Coriolis effect? It simply means deflection. Now, another thing or another important thing related with Coriolis effect is, it is caused because of the rotation of the earth. See, you shouldn't be confused. The Coriolis effect is only due to rotation of the earth, say revolution or gravitational effect or distribution of the landmass. None of these things influence or results in the deflection. The deflection is only because of rotation of the earth, and I will show you how the deflection is caused because of the rotation of the earth. Now, see, if you are observing the earth from the north pole, now which will be the highest circle you will be seeing, highest latitudinal circle? It will be nothing but it will be equator. Okay, now see, if you are seeing the Arctic circle, it will be a smaller latitudinal circle than the equatorial circle, right? Now what about the poles? It will be a single point. Now consider 2 points in these latitudinal circles, A and B. See, suppose after 12 hours it is rotating, right? The earth will be rotating, and in which direction the earth will be rotating? West to east, west to east. But again, west and east, they are always relative. We cannot simply say that the earth is rotating in west to east direction. Rather than, see, if you are observing the earth from the north pole, it will seem like the rotation will be anti-clockwise. Say, if you are seeing say, this is west and this is east, right? Now if you are seeing or if you are observing from the north pole, the rotation will be anti-clockwise. The same rotation, it will be clockwise if you are observing from the south pole. So always be sure that, or be aware that, the rotation of the earth is from west to east, and it is explained if the observer is observing from the north pole. Now the rotation will be anti-clockwise. Now say this is it is having anti-clockwise rotation, and it will be rotating in this direction, right? Now after say 12 hours, the point A will reach here. Suppose point A1. Now the point B will reach here, point B1. Now consider the distances travelled by these or both of these points. The point A travelled this much distance with 12 hours, right? Now the same amount of time, the point B travelled only this much time or this much distance. So the more distance travelled with the same time means the equatorial circle or the equator is rotating with higher speed when compared with the other places. Say, I am not saying that Earth is rotating separately or these places are rotating separately. Rather than, the effect or this rotational effect is felt throughout the earth differently. Okay, the rotational effect will be more felt towards the equator region, and will be less towards as we progress towards pole, and at the north pole or south pole the rotation will be 0. Okay, now suppose, so from this explanation we have seen that the earth is rotating with more speed at equator when compared with the other places, right? Or the rotation is 0 at the pole regions. Now suppose say a wind is moving from a high pressure region which is situated near to the equator, say subtropical high pressure belt, towards subpolar low pressure belt. Now, the wind is moving from a place which is having high rotational effect towards a place which is having low rotational effect. So that this will result in relative motion. Say at the starting of this movement, the wind wanted to reach here, but by the time the wind reached here, the place or the place will be rotating slowly, so that the wind will get overshoot, or wind will get deflected towards right, if this is happening in the northern hemisphere. The same moment, say a wind is moving from equator to poleward region in the southern hemisphere. This deflection, it will be towards left. See, you should understand that this left or right is not related with the observer. I am not speaking about the left and or my left and right. Rather than the left and right is of the movement of, or it is dependent on the direction of this wind. Say, which is the right of this wind? This right. This is right and this is left. And say, suppose this is a wind movement, which is the right and which is the left. This will be right. Again, this will be left. So the same way, if the wind is moving in the southern hemisphere, again it is moving from places having high rotational effect to places having low rotational effect, so that it will get deflected, it will overshoot, so that this deflection will come out as like towards the left of the movement of the wind, okay, or towards the left of the path of the direction of that particular wind. So the next point you should understand about Coriolis effect is its deflection, or the physical effects of this Coriolis force. The deflection, it will be towards right of the path of the direction of that wind in the northern hemisphere, and this in southern hemisphere the deflection will be towards the left of that direction of the wind, right? Clear? Now, another point you should note down is how this Coriolis effect affects the other cyclonic circulation or anticyclonic circulations, or generally wind patterns. Suppose this is a low pressure region in the northern hemisphere. Okay, if there is a low pressure region, the tendency of the wind will be to occupy that low pressure region, right? Wind will move towards that low pressure region from all the other directions. Now, if this is taking place in the northern hemisphere, the deflection will be towards right. Again, this also will get deflected towards right. Now, if you see the big picture, you will understand that the wind will not be able to occupy this low pressure region because of the Coriolis effect. Rather than it will spin around this low pressure region. And if this low pressure region is situated in the northern hemisphere, this spinning or this rotation, say it is anti-clockwise or counter-clockwise direction. So, the northern hemisphere, the cyclonic circulations, the rotation will be anti-clockwise. Now, if the low pressure region, consider the low pressure region is in southern hemisphere. Now, again the wind will try to occupy these regions, right? But in this case, the rotation will be towards left, say, which is the left of this particular wind. It will be towards this, right? And the left. Now, if we see this rotation, it is actually clockwise in direction. So that we can say that for the cyclonic circulations, meaning that the center is having low pressure region, for the cyclonic circulations, the rotation will be anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Okay. Now just suppose, what if the center is having high pressure regions, or what if we are having anticyclonic conditions? Anticyclonic conditions means we will be having high pressure at the center, right? Now again, suppose if this is happening in northern hemisphere. See, if there is a high pressure region, the tendency of the wind will be to move or to blow away from that high pressure regions towards other regions, right? Now, if this is happening in the northern hemisphere, in which direction will it get deflected? Towards this direction, right? Now, if we connect this rotation, or if we see this rotation, we will understand that in the northern hemisphere, if it is anticyclonic condition, we will have a rotation, clockwise rotation will be there, and the opposite will be there, like in the southern hemisphere it will be anti-clockwise rotation. Okay, so these are the physical effects of Coriolis force or Coriolis effect. Now, these physical effects, they are really important for you. You should be always aware about the influence of Coriolis effect on wind patterns and how it is caused. Now, I will just again go through the topic, like it is caused because of only rotation of the earth. You shouldn't be concerned with any other factors. And what are the physical effects? In the northern hemisphere, the deflection will be towards right of its path, and in the southern hemisphere, the deflection will be towards left of its path. And how does it affect the cyclonic and anticyclonic conditions? In the cyclonic conditions, the wind pattern or the rotation will be anti-clockwise in northern hemisphere, and in southern hemisphere it will be clockwise, and the vice versa will be the case of anticyclonic conditions. So you can study this, and you can by heart that it is opposite in the case of anticyclonic conditions. Now just go through that question shown in your screens. See the year 2010 question. Now, what causes wind to deflect towards left in the southern hemisphere? Again, an ABCD question. You should understand that you should be knowing all the options, then only you will get to the answer, right? See, what causes the wind to deflect towards left in the southern hemisphere? We know that it is due to the Coriolis effect. Okay, or if you go through that options, you will understand that, say, temperature or magnetic field. The third option, rotation of the earth, and the fourth option, pressure. Why the wind is getting deflected towards left? It is because of the rotation of the earth, and Coriolis effect is only it is taking place only because of the rotation of the earth. Now see the next question, 2005 question, assertion reason type question. The UPSC generally don't ask this pattern or the questions of this pattern recently, like this is an old pattern question. Again, that topic is important for us, right? Let's just go through that assertion statement. Wind patterns are clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Is it true or false? Wind patterns are generally anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. So that the first statement is wrong. Now just go through the reason statement. The direction of the wind patterns in the northern and southern hemisphere are governed by the Coriolis effect. Okay, we know that it is true. The deflection is only because of Coriolis effect. So the answer will come out as A is false but R is true. Now see the next question. And this is a more recent year question. The question is related with Vestal ice, but you can see in the options Coriolis force is there. Now just go through the question. Vestal ice in southern hemisphere are stronger and persistent than in the northern hemisphere. We know that, say, roaring 40s or furious 50s, striking 60s, these are there in the southern hemisphere. And southern hemisphere, their constancy is because of the irregularities are less there in the southern hemisphere, because we are having more landmass situated towards the northern hemisphere. Landmass is less in the southern hemisphere, and because of this reason, the Vestal ice will be more constant in the southern hemisphere compared to the northern hemisphere. Okay. Now the first statement, southern hemisphere has less landmass as compared to the northern hemisphere. It is true, right? Now go through the second one. Coriolis force is higher in southern hemisphere as compared to the northern hemisphere. So just imagine, does Coriolis force change according to the hemispheres, or is it under the influence of different hemispheres? No, it is only under the influence of rotation of the earth. The landmass or the gravitational force or say any other forces don't cause the Coriolis effect. So this is all about Coriolis force. I'll be coming up with more videos. See, it won't be possible to discuss all the concepts, rather than I'll be discussing selected important concepts through this video series. So, thank you.